Hello everyone, it's a pleasure meeting you all in my mathematics class. Today I have taken up this problem which is a partial differential equation. You have to solve this for z, and z is a function of x and y, and p is dou z by dou x. This p is dou z by dou x. Q is equal to dou z by dou y. Now to get the solution for this problem, I will call this as 1. So in all the problems here we have got different types, and only when you can reduce the given differential equation to a particular type whose solution can immediately be written, then only we say that the problem is solved. That means, if you are given a differential equation, identify it, apply a proper transformation and bring it to a standard type, a known type whose solution can be written. So this is the method. See how I write this. See, 1, it can be written as, it is x to the power of 4 p squared minus y z q is equal to z squared. So I write it in this way. Now I divide throughout by z, so this implies it is x to the power of 4 p squared z to the power of minus 2 minus y, it is z to the power of minus 1, q is equal to 1. I divide throughout by z square because this is z square, when it goes to the numerator it is z to the power of minus 2, and 1 z and 1 z will go off, but when z goes to the numerator it will be z to the power of minus 1 is equal to 1. Now you see that this is something of the form like this. Actually this is of the type f of x to the power of n p y n q z is equal to 0. So this type. So if I can bring this, see, transform this to a type of f of pq is equal to 0, so that the solution can be written as z is equal to ax plus by plus a constant c. So what should we do now? So this is of the type f of these x, m and n are not equal to 1. See, m comma n not equal to 1. So you see that this is the differential equation of the type x to the power of m, y to the power of n q, x to the power of m p, y n q z is equal to 0. If you want to solve this, you must use proper transformation and take care to see that this m and n are not equal to 1 here, in this here, and reduce it to the form of f of pq is equal to 0, a differential equation of this type, whose solution can be written as this, where a, b, c are constants. So this is all about how to approach the problem. Now let us start doing this. See. Now, so let us find what transformation we can give. See here this can be written as, so this is x square p z to the power of minus 1 whole square minus y z to the power of minus 1 cube is equal to 1. See what you see, you must understand one aspect, that a proper transformation means a transformation must be able to reduce this to a form f of pq is equal to 0. So these two must be changed to another partial differential equation, capital P and capital Q. and we must look for that particular transformation which can bring it to that form. Now, here what I do here is I choose, see, take, I will write it here, take x is equal to x to the power of minus 1. And this m and n, see, this is not equal to 1. And here y to the, if it is 1, then I will, see here you must know that here n, y to the power of n, y to the power of n, n is not equal to 1. But if n is equal to 1, suppose you have it like this, then your capital Y must be equal to log y. That is, we have to take log of that function. So that is the transformation. Big simple reason is that only when you take like that, this 2 can be brought to capital P and capital Q, which are nothing but the transformed partial derivative of z with respect to x and y. Okay, nothing more than that. So this implies dou x by x is equal to minus 1 to the power of x minus 2. This implies dou x by dou x is equal to minus, it is it is what, x to the x square. You can write it like this, see, minus 1 by x to the power of minus 2, it is minus x square. Likewise here, as I told you, here this y is, you take this y as log y, so that dou y by dou y is equal to 1 by y, and take capital Z is equal to log z, so that dou z by small dou z is equal to 1 by z, which implies dou z by dou capital is equal to z. See, why I take this, you will understand. If you take like this, if you take it in this form, the transformations, then only this can be reduced. The simple reason is that. Now, see, I write here. Now, what is our P actually? P is dou z by dou x. I use, now I must go for a transformed partial derivative. How do you write that? Dou z by dou capital Z into dou capital Z by dou capital X into dou capital X by dou X. Now what is this dou Z by dou Z? See, I have written here. Dou Z by dou Z is Z. So this is Z. And this is nothing but your capital P. So this is capital P. And dou X by dou capital X by dou X. Dou capital X by this is minus x square. See? That is equal to minus P into Z x square. So this is our P. This is our P. So this implies minus P. Okay. So this gives, see, it is only, as I told you, you must choose that transformation which will make this particular that is the partial derivative with respect to capital X and capital Y. That's all. So this is minus P is equal to, take it to the other side, P divided by x squared, that is equal to P to the power of P. Yes. It is minus 1. Say, I am writing it here. Dou x by dou x is minus x to the power of minus 2. This is. See, dou x by dou x, this is. Dou x by dou x is minus x. So this is nothing but what? So P by So you can identify this, see here, x square p. So I am able to replace this by minus. So our transformation idea is, the basic idea behind taking a proper transformation is to get these two in purely in terms of the capital P and capital Q. That's all. Now likewise, what is that you will get here now? Q is equal to dou z by dou y, which is equal to dou z by dou capital Z, dou capital Z by dou capital Y into dou capital Y by dou Y. So now what is this dou Z by dou Z? See, dou Z by dou Z, see, it is your Z and this is your Q, and dou Y by dou Y is 1 by Y. So this implies Q is equal to Q into Z by Y, which implies Q is equal to YQ divided by Z, that is equal to YQ Z to the power of minus 1. So Q is equal to YQ Z to the power of minus 1. So we are able to get this Q as it. Now YQ, see, YQ Z to the power of minus 1. So we have got the two results, namely, what are those things that we have got here? Minus P is equal to, it is P Z to the power of minus 1 x square, and Q is equal to PQ, it is Z to the power of minus 1 y. See, we have got, now these two can be, you can replace this, see, you can just substitute these values here. I'll substitute and get you the answer. So this is what we have. So now call this as your 2, call this as your 3, and take this as your 2. See, I will take this as my 2. Now let us substitute this 3 in 2. So substituting 3 in 2, so substitute 3 in 2. So this will give you, so this place I can write it as minus P whole square minus, see, this is, yeah, the minus P is equal to 1. This implies P square minus Q is equal to 1. Now this is reduced to F of PQ is equal to 0. Some constant is, this is equal to 0. Now the solution for 1, see, I call this as your, see, solution for 4 is, see, solution for, see, we have found, see, take P is equal to A, Q is equal to B, then we get A square minus B is equal to 1, which implies B is equal to A squared minus 1. See, the solution for this 4, take this, then the solution is given by, say, it is capital Z, okay? The solution is capital Z is equal to A capital X plus B capital Y plus C. This is the solution. Now this is nothing but, so this is equal to A X plus B, we have got this. We are able to express it in terms of this x a squared minus 1 into y plus I will take it as, okay, I will call this as B, no problem. We can call this as B or B dash, whatever. Because having taken this B expressed in terms of A, I can call this as my B. Now A and B are constants. A comma B are, they are constants. Now this is a solution. See, this is a solution. So we have got the solution. So what is that I have done here? I have not done anything except that given a problem like this, I am able to identify the type. I cannot straight away get the solution. So I go for a transformation. Using the transformation, I am able to bring it to the form f of pq is equal to 0, whose solution is given like this. Now we take p is equal to a and q is equal to b. That way we are able to get the constant a and b in terms of a plus another constant will be there. Now this is my solution. This is the general, this is the complete solution for the problem. This one I will call this for the problem 4. For the problem 4. Now, see what is the solution? Therefore, the complete solution. So, therefore, complete solution for 1. Because I am bothered about this problem only 1. What is the complete solution for this? The complete solution is wherever the variable, new variable has come, replace it by the old variables. What is z? It is log z is equal to, it is a into, it is x to the power of minus 1. Because we have taken capital X is equal to x to the power of minus 1 plus a squared minus 1 into log y, because capital Y is equal to log y plus a constant. This is the complete solution. Call this as your C, we call it as. So this is my solution. So call this as your, this is the solution. Let me name it as capital 1. Now you see that this is the solution, and if, so the general solution can be obtained by taking B is equal to A. Take B is equal to A, express B as, take B is equal to f of A, take B is equal to f of A, then log z is equal to a by x plus a square minus 1 into log of y plus f of a. Call this as your 2. Call this as your differentiate. Now differentiate two with respect to a. So if you do this thing with respect to a, this will be 0. Some factors will come here. That will be 0 minus equal to my a 1 by x plus log y into a squared minus 1 square root of this, derivative of this, take the derivative of this plus f dash of a. Call this as solve 2 and 3 to get value of a. Then the resulting solution is the general solution. Alright, this is the general solution. So the general solution is obtained by taking b is equal to f of a, differentiate it, then that's all the equations here. Now, see, differentiate here, you see that we are taking this. This is our solution. This is our solution. So we have got like this. Log z is equal to, it is a by x plus a square minus 1 log y plus b. Now you differentiate this with respect to b, then this will be 0, this will be 0. This will tell that differentiate with respect to b, then we will get 1 is equal to 0, because here you see that differentiation of b with respect to itself is what? 1 is equal to 0. This is an absurd result. Therefore, no singular